Hello, welcome to Secure Talk, your trusted source of information on the latest threats, trends, tools, and technology related to cybersecurity and compliance.
Hey, Steven, how you doing today?
Hey, Mark. Great, thanks. How are you doing?
Awesome. Hey, you said that you're in Spain. Whereabouts in Spain, and how did you end up there?
I'm up in the northern part of Spain, so the easiest way to describe it is kind of northeast-ish. So 5 hours north of Madrid, 3 hours west of Barcelona, and about 30 minutes from the French border in the Pyrenees.
Sounds awesome. I'm American, so it's Europe, okay?
It's Europe, yeah.
You're in Europe, okay.
We're in the hot bit of Europe, yeah.
Right, okay. So I think you might be possibly the first person that I've interviewed or spoken to in the cybersecurity space who's living in Spain. We have a lot of people in North America, some people in the UK, Germany, and quite a few people in Israel, of course. But I think you're the first person in Spain. Are there any other cybersecurity startups, or is there an ecosystem there?
There is. And probably the most famous company that you've probably heard of is AlienVault.
Oh, yeah.
So AlienVault was a Spanish company that eventually moved to the US and expanded into the US. And there's another company called HDiv that was recently acquired by Datadog.
Okay.
I think there's quite a significant cybersecurity ecosystem in Spain, but they tend to kind of fly under the radar, and some tend to be just wolfed up by larger American companies.
We have a way of doing that, yes.
Yeah,
Wolfing up companies. Hey, I want to get your thoughts in terms of the regulatory landscape in cyber and also what the current threat landscape looks like. And you actually just brought up the business, the funding side of things. And I want to come to back to that at the end too as well, because I think there might be some advantages, there might be some disadvantages of trying to go after funding if you're not, located in Palo Alto, downtown, if you're on the other side of the planet. But before we do that, maybe we can just do like a level set and just tell us your elevator pitch. What does IriusRisk do?
So what we do is we're an automated platform, and it allows engineers, AppSec professionals, security champions to draw a design of their application or of their cloud architecture, and we automatically generate a threat model of that design. So we automatically say, if you're going to build this kind of application at a design level, these are the security threats you need to be aware of, and these are the security controls you should implement, and these are the security controls you must implement in order to comply with your own internal policy. So we essentially allow non-security experts to understand, before they go and build something, what are the security risks that I'm facing with this design, and what is the security work I need to go and do to implement a secure version of this application.
So then what are you looking at if nothing's been developed? You're looking at, hey, this is the use cases, the functionality that we're going to try to build. We're going to have X type of data, customer data, patient data, these people accessing. I mean, walk me through that. Yeah.
It's a combination of the components you're choosing to use. Mm-hmm. So, for example, you're building an API. I'm going to deploy my API on an EC2 instance. That API is going to make a call out to a third-party SaaS service. And we're going to be sending customer data to that third-party SaaS service, and we're going to be storing data in an S3 bucket, and that S3 bucket is in a different geographic location. So there's a lot of security meta information available in that design, including some of the more detailed things like, okay, I'm using an API, I'm going to build it in Python. It's going to allow funds transfer, and I'm going to authenticate the user by generating a random token, right? So with that information, that's enough to already understand what are the security risks that I'm facing with that design. And I already know what are the kind of security controls I should have and I should watch out for if I want to go and implement that. So what we're really talking about here is truly shifting left in application security to the point where you don't have code yet, but you have a design. You have an idea of what you want to build. And from that, you can already understand what are the security requirements that come out of that.
It's very interesting because typically, like if I ask somebody to say like, okay, you're going to give a CISO some advice. He's just started first day on the job. What should he do? And a lot of times it comes back and says, you got to understand your risk level. What's at risk? What do you have? You have to do an assessment of what do you have that you need to protect, whether it's devices, data, so on and so forth. And then you have to, once you understand what you're going to protect, you have to kind of rank it in terms of priority. Like this absolutely has to be 100% locked down. This, we're okay with 80%, something like that. but you're talking about a preemptive before anything's built going in there, which is awesome. And it's the first time I've heard of this. Who do you typically engage with, and when do you start the engagement, and how do you find these people?
So we usually engage with the application security teams or product security teams. And if those teams don't exist, then we're talking to the wider cybersecurity organization. Most of our customers are teams who are already doing this. So they're already doing threat modeling, but they're doing it manually. So a typical approach is they will have a process where architects out in the engineering organization will design either a completely new solution or they'll design a change to an existing system. And that design is a combination of maybe even a set of PowerPoint slides or a Visio diagram with a Word document describing this is the design of the thing we're going to build. They email that over to the central security architecture team, and the central security architecture team looks at this, analyzes it, asks them some questions, and then produces a report and says, these are the risks we identified, and this is what we expect you to do for each of those risks. And maybe this thing you don't have to worry about. We can accept the risk here because it's not that serious. So we do that, but in software. So we free up this team and we give our customers an ability to scale this activity so that those architects out in the engineering org, and usually there are an order of magnitude more engineers than security people, they can self-service. They can log into IriusRisk and they can do all of this themselves and get the result without having to engage with a central team.
In order to automate it, you have to collect that information in some type of format that allows your machine or your platform to evaluate it. So walk me through it. I actually, for our listeners, I didn't mean this as a promotion of IriusRisk, but I haven't actually come across this type of platform before. I'm intrigued because if you're going to automate a response to something, you need to feed that some kind of structured data or information. So how does that work? Because you just mentioned like, oh, well, the engineer draws something up and then they send it over and the other team looks at it and da-da-da. But you can't do that with this. I mean, so walk me through that.
You hit the nail on the head there. You need to do it in a structured format. And you'll see one of the books behind me, they seem to be reversed, but one of them is about patterns, right? And when we think about architectural patterns and when we work towards patterns, we can predefine the threats and the controls associated with those patterns. So the way we've built IriusRisk is we have an extensive knowledge base of what we call risk patterns of threats and controls that belong together for a grouping that we've decided on, right? We've said, okay, these threats and controls belong together for a particular reason. And then we have a rules engine that says, if somebody has drawn a diagram using component A and component B, and there's a certain type of data flowing between component A and component B, then go and pull in that pattern because that pattern is applicable to this scenario in the architecture. And that's essentially how we've automated it. As we've predefined a lot of components, we've predefined types of data, and the user can then go and configure the system to say, I'm using this type of data, I'm using this type of component that has these characteristics, and then our rules will execute on that and make those kinds of decisions on the system.
That was kind of a general description. Can you give me a very specific use case of a pattern that we might all kind of recognize?
Sure. Let me first say that one of the cool things about the patterns is you can state them quite generally, and then you can build more specific patterns for more specific scenarios. So a good example of this is we've got one pattern that's called server-side authentication. So this pattern says, by its name, it says we apply this pattern whenever there's any kind of server-side authentication, and don't care what protocol is used. And don't care what type of authentication you're using either. You could use multi-factor or single-factor or whatever, but there's some kind of authentication and it's happening on the server. So when we scope it like that, we can then say, okay, so what are the threats that would apply in any kind of technology where there's server-side authentication, and I don't care about the type of authentication either. So we will come up with 2 or 3 threats that would apply there, and we would come up with 2 or 3 controls that can apply to those threats. And we say, okay, that's our pattern. Store that in our knowledge base. Now, over on the other side, we then we've got some predefined components, and one component will be something like a web API. Another component will be web server. Another component will be TCP server. And all of those things, although they use different technologies, all of those things are servers. If any of those 3, I could say they do authentication we can then deduce and say, this is a server-side component. It's doing authentication. Therefore, that pattern applies. And we will pull that into the model automatically. And all the user has to do is drag the right component, say, I'm doing a TCP service is doing authentication. And we now know what risk patterns apply in that particular scenario.
And what's their action item, whether they have something or not have something? I mean, is this like a tool then it says, hey, here's an issue that you have to address? Just trying to think about what's the follow on.
Yeah.
Yeah.
Great question. So because this tool is really aimed at engineers and people who are building stuff,
right,
the output needs to be usable by them. So the output we create is a list of threats. So these are the things you need to be concerned about. And for each of those threats, there are recommended and required countermeasures. So this is the countermeasure I'm going to implement or should implement to reduce the risk or to completely eliminate the risk. And each of those countermeasures can become tickets on Jira. So the usual workflow is for somebody to draw their diagram, answer questions on the components. So they give the characteristics of each of those components, click the button that says generate model. They get the model that says, these are your threats. These are your countermeasures. They can then go through the threats and they could also say, well, this threat doesn't really apply to me. I understand why it's here. I'm doing something special and this doesn't apply. They can mark that as not applicable. They could choose threats and say, I want to accept the risk here. So they can accept the risk. They need to provide a reason. This gets audited. So that kind of decisions are stored. And ultimately, they can then go through the countermeasures that are left over and say, create tickets on Jira or on Azure DevOps as tasks for me. So those countermeasures become tasks on the development team's backlog. This is turning into a pitch, but I'll go ahead.
It's all right, man.
So one of the cool things is that
as long as you don't have a big IriusRisk banner behind you, right? Oh, okay.
So you can, as a developer, you've got this new tasks. And a very typical scenario is someone like a security champion, a developer who's been baptized as you're the security guy, you need to take care of security within your team, but you're not necessarily an expert in security. They would go in and do this threat model in IriusRisk. They'll do that initial triaging of the threats and the controls, and then push the rest of the countermeasures up to Jira. The rest of their team is maybe even unaware that IriusRisk exists as a system, and they just see, I've got 20 new tasks to do. They're all tagged with security.
Thank you, IriusRisk, for these 20 new tasks.
Yeah. I got more work. Yay!
Said nobody ever.
Yeah. They can mark those tasks as done in Jira, and we automatically update the threat model. Right? So they automatically get a view saying, we're reducing risk. We're getting to where we want to be from a security perspective.
Awesome. Hey, just two more questions. One is, does this help with the attainment of any kind of regulatory or compliance? For example, ISO 27001 or SOC 2. Can I use this to facilitate that? And the second question, I'll just get it out now, is how do you charge? What's your fee structure? Mm-hmm. So they're not really related questions, but I just want to throw them out there, and then we're going to move on to a different topic.
Mm. So the area of threat modeling is not that new. I think Microsoft released the first book on it in probably 2004 or so. Microsoft did a lot of early work on threat modeling as a key part of their secure SDLC. But it's been mostly kind of delivered as consulting or as training and so on. And it's only fairly recently that we've seen regulation come out specifically around threat modeling, and then more generally around this concept of security by design and secure by design. So for the threat modeling regulation, what we've seen this year is that now the FDA will not license a medical device for sale in the US unless there's a threat model for that device.
Whoa.
Which to me, because I'm in the field, seems like a perfectly logical thing to do.
No, because I'm thinking about you're like a pacemaker or whatever it is. If it gets hacked,
yeah,
or just some wow. Okay, go ahead. I'm sorry, cut you off, but yeah.
And
I mean, but you said FDA, and when you said FDA, I was like, he got the acronym, the abbreviation wrong, because like FDA cybersecurity. But go ahead. No, you got it. Yeah,
no, exactly, and it makes complete sense because the threat model acts as a form of communication from the vendor to the regulator, like the FDA, saying, "Look, this is how we thought about the security of this device. Here are our assumptions. Here are the things we identified as that could go wrong with this device, and these are the controls that we implemented against that." So it's really a communication tool and something the regulator can look at and see, yep, I agree with the way you looked at this. I agree with the controls that you've put in place for these particular threats. And I agree with the overall list of threats that you identified. So I think it's a really good way to give that kind of transparency from the vendor to a regulator, saying this is how we're thinking about the security of what we're building and what we're ultimately implanting in human bodies. We've seen similar regulation in the industrial control devices space.
Yeah, that's huge.
Similar kind of thing. And that also touches on critical national infrastructure. A lot of these devices are running things that are critical to the operating of society.
Nuclear power plants and stuff.
For example, yeah.
I just, what do they have in Switzerland? That super collider that's like 70 kilometers and it just like blows up subatomic stuff and nobody knows what's going to happen. And I'm thinking like, you better make sure that stuff's secure, man. You don't want that stuff hacked.
Don't want a black hole in your backyard.
No, not in my backyard.
Yeah. And then more generally, what we've seen come out 2 months ago from the White House was the National Cybersecurity Strategy. And so this is like a high-level cybersecurity strategy document, but they use the phrase secure by design about 5 times in that document. And what secure by design means to me is that you literally have to think about the security of your design. Think about what is going to go wrong with this thing we're building before we go and build it. Make those decisions there, because it's a lot cheaper to change your mind than to go and change a piece of software or even hardware that you've built after the fact. So make those decisions early at design time. Then you go and build it according to that plan. And then you can even go and test according to your plan, right? So you can define what are you worried about, what do you expect to see, what do you expect to build, and how you expect that to behave. So my early career was in penetration testing and break applications. And we always went in with a kind of a black box approach. We're just given a URL and maybe a login and like go and break it. We had to figure out what this application is meant to do. And sometimes it's obvious, but sometimes it's not. If we had a threat model as a kind of an informed way to understand, like, this is how this thing was built. This is what the company is really concerned about. They're really concerned about this threat. This is why they've implemented those 5 controls. If one of those controls fails, that's critical. And that would allow a tester to be a lot more informed about where they should spend their time and what they should be testing when they go and test something.
Makes a lot of sense. And then in terms of how you charge,
yeah. So how we charge is we license per threat model within the IriusRisk platform. So you can buy a 20 threat model license and you can expand to a 30 threat model or hundreds, 200, 300s of threat models.
Is it same pricing based upon enterprise size or is it different?
No. Enterprise size doesn't matter. It's just purely the number of threat models that you have. Naturally, if you're an enterprise, you're going to have more threat models.
Makes sense.
But importantly, we don't charge by the user. So you can have thousands of users, makes no difference. The value you're getting from the software is really based on how many models you have. So that's where we've put our price point.
And do you offer some type of free demo, POC? I mean, typically with software, people can try it out. But if they try it out and they see their threats, then they're like, thanks, we're out of here. I mean, how does that work?
So we do offer a free community edition. And in fact, it's at community.iriusrisk.com. You can also find it from our website. And you can log in. You will have full access to our knowledge base. So you can design the same kind of systems that you could in our enterprise edition. The limitations are that you don't have access to the API. You can't integrate with Jira, and you can only do one threat model. So that's kind of where we've put or drawn the line between. I'm
going to go out and get 30 demo
paying
accounts and do 30. No, I'm just joking.
You can. It's even easier. It's even easier. You can delete. You can do a model. You can export it. You can delete it, and you can do the next one.
All right.
So we want people to use the software,
sure.
And if you're the kind of company that isn't going to buy an enterprise threat modeling platform, by all means, use Community, get value from it.
Awesome.
And maybe we'll be talking in a year or two.
Hopefully so. You started to touch on the regulatory environment, and you started talking about some of the new cyber legislation coming out of the White House, security by design, and some other things. What else are you seeing in terms of the current regulatory landscape, whether that's in North America or in Europe or wherever?
Yeah, so funnily enough, the EU is famous for coming out with strict regulation. In this case, we're seeing the US lead the way. The EU has a Cyber Resiliency Act, which is currently in place. But in terms of what they're asking of software vendors, it's quite broad. They require software vendors to do risk assessment of their software. They require them to implement adequate security controls. Up to them to define what adequate is.
I like that. I like that kind of legislation. Get some adequate or appropriate or...
Yeah. So then you're not going to like the US legislation, which says, any piece of software
Too
that's
specific.
it's very specific. Yeah. Currently it applies to software that's being procured by the federal government. They need to comply with a NIST standard called the Secure Software Development Framework, the SSDF. And in the SSDF, there are a number of activities that you need to do. And you need to show that we've done all of these things in order to assure you that we have built secure software.
Where does the SBOM come into play on that? The software.
So the SBOM, I know maybe I need to be corrected here, but I believe it's part of the SSDF.
Okay.
And if it isn't, then it's part of the executive order that came out of the White House. The general theme that's coming out of the US regulatory landscape is that software vendors need to be held liable for the security of the software they're building. And that's something that you expect in every other thing that you purchase as a consumer. When I buy a television set or I buy a car, if something goes wrong with that from a safety aspect, it's the vendor's fault. They didn't build the thing correctly.
What about vaccines? Okay, never mind. I didn't say that. I'm gonna lose all 21 of my subscribers on YouTube now.
So in a way, I think software is playing kind of catch up in the regulatory space with a lot of the other engineering disciplines that have been doing this for many, many years. And it's good to see it. I think it's necessary. Our lives depend on software and increasingly so. If
you think about it, a lot of times people think about software. Obviously, the people who listen to this, they get it. But your general consumer thinks about software as, well, it's something on my computer, but it's something that's driving your car, man. It's those airplanes, they're on software. And like you mentioned, the medical devices, industrial devices, it's everywhere, man. So yeah.
It's everywhere. Absolutely. Yeah.
So what I'm hearing you saying is the newer U.S. regulations are getting quite specific and they're holding software vendors accountable to protect or and then I guess would say update and so on and so forth, monitor their software. What would you say are the biggest threats in the context of what we've been talking? What are the biggest threats out there? Is it malicious actors? Is it disgruntled employees? What are you seeing?
First, let me caveat my answer with I'm going to answer within my area of speciality,
Sure.
which is in kind of software security. And there, in terms of the threat actors, I think we work a lot with kind of finance, fintech space, as well as the device manufacturers. So I think cybercrime is a big one. There's clear motivation for them to launch attacks. There's a payoff. And this is particularly true for chain, crypto, those kinds of sectors, because you don't need to do something complex like ransomware and then set up a thing so somebody can pay me if I do something bad to them. No, you can just literally transfer funds from one place to another. So that's a big one now, and it's going to be even bigger as we do more and more on finance, on our apps, and in software in general. The nation state space is an area I'm not very familiar with. So I think your readers are probably more informed about that area than I am.
Stick on that first one there, though. What form of attacks are you seeing? You talked about crypto, but like maybe could you be a little bit more specific in terms of what you're actually seeing? Is it just malicious code? Is it?
So it's flawed code. It's not that the attacker. So yes, the attacker is attacking a piece of software, but that software has a bug in it or has a software flaw in it. Like there's a mistake in the code, and the attacker has just found it and figured out, well, how do I trick this application into doing something it's not meant to do? And this is, very true for the crypto space. And the thing that's really intriguing to me there is that many of the crypto attacks haven't really been technical attacks. They've been kind of financial attacks. And this is where you need to have a kind of a finance background to understand what they did here. They drained liquidity over here and then increased liquidity over there and then borrowed funds from this place. And that combination of things allowed them to get money from a place that they shouldn't have been able to get it to. So that it was the kind of the financial structure of the whole thing that was vulnerable. And that was what the attacker exploited. So those kinds of things to me are super interesting, because it's not just there's a buffer overflow and I found it and exploited it and ran some malicious code there. It's exploiting more a complex system.
Well,
as an attacker,
you can talk about like arbitrage opportunities with crypto. You can talk about about front running. So if I can see a large transaction and I can get out in front of that transaction and buy whatever they're going to buy ahead of that transaction, I'm going to get that uplift, right? And so here's my question, because you're talking about them spotting a bug or a weakness. How do they do that? Because it sounds like some of the same skills that they would be using could be applicable to the type of platform that IriusRisk provides, right? I mean, where you're trying to get out in front and see where there's opportunities there. But how do these bad guys do it? Unless are they using IriusRisk? They're your biggest customers.
So they, depending on what they're attacking. So if you're attacking a banking platform hosted by a traditional bank, you don't have access to the code. You don't know how it works. So you're blindly trying things. You're seeing how the application responds. And based on those responses, you're trying to craft a way that you can do something here. I'll maybe mention an anecdote. I was involved in a penetration test on a banking application. One of my colleagues found a really cool flaw. So this was a commercial banking application. Between banks, you could do currency transfer. And what he found was that you could transfer 1 US cent into a Ugandan currency. And I don't know what the Ugandan currency is, but let's just say Ugandan currency. So 1 US cent equals 43 Ugandan units. I said, okay, cool. What happens if I transfer 43 Ugandan units back into cents? Well, I get 1 cent. Cool. That works. What if I transfer 28 Ugandan units into US cents? What do I get? 1 US cent.
Whoa. I'm going with the 28.
Yeah. So you could do this operation over and over again, and your balance just increases because you're just making money from nowhere on a rounding error because there wasn't a unit smaller than cents in the system.
Wow.
So those kinds of flaw, that's a logic flaw. That's not it's not a buffer overflow. It's not an SQL injection. It's none of those things. It's just the way the application was designed didn't take that into account, and you can find those kinds of flaws. In the crypto space, I think it's, well, in some ways more challenging, but also in some ways easier because the blockchain, the code is available for you to look at. A lot of these chains of open source code. So you can go and read the smart contract. You can understand what the smart contract is meant to do. And then you could figure out, okay, so if this is the contract, these are the assumptions the contract writer made. What happens if I did this? And let's see how that works. What happens if I did something else? So you have a lot more insight because you can literally go and read the code and understand how it's meant to work and then figure out, well, how am I going to attack it? What am I going to send it for it to behave differently?
No, it's funny because I just interviewed the CEO of a Israeli cybersecurity company that specializes in security for DeFi platforms, decentralized finance platforms. And she made it very clear that if you are a traditional cybersecurity expert, and that even that's such a broad term because there's many different areas of specialization you could go into. But if you don't have that DeFi, blockchain, crypto experience, a lot of your skills, they will transfer, but you're still going to have some big gaps in terms of your knowledge of that threat landscape because it's completely different. And which what you just described, if I'm sitting at my typical Fortune 500 company selling widgets or services or whatever, I'm not looking at those kind of threat landscapes. I'm looking at more the phishing, or do we have MFA turned on, and so on and so forth. And in the software, is there some faulty code, but not in terms of looking for these arbitrage opportunities. Well, maybe, I guess if I was in the financial services space, maybe I would be. Which brings up the question, okay, I'm a bank. I'm not crypto, no decentralized finance, but I'm a bank. How do I go and spot these the rounding error issues.
That's where I think secure design really shines, because in theory, you would be able to find that by looking at the detailed design documentation and or the tasks that the developers went and created to go and create that functionality. So somewhere there's a piece of text that somebody said, and we will only support cents with a 2 decimal points behind the dollar for all US currencies or for all currencies. So somewhere somebody spec'd that and said that's going to be the case. So it's at that point that if you had analyzed that design, somebody with an attacker's mindset would have looked at it and go, but what happens if I transfer an amount that is less than a cent? Do you round up? Do you round down? Do you cut it off? So I think it's possible to find those kinds of things early on. And if you do find them early on, that's a lot easier to fix than once your application is pretty much deployed in a test environment or even deployed into production. And now you're going to go and find and get testers to find these kinds of issues and then try and fix it and redeploy and so on.
I just think about what the whole world, and probably half the listeners won't even know this, hadn't lived through it. But during the whole Y2K thing, it's like, when did somebody go like, maybe literally like the whole planet thought it was like, we don't know what's going to happen, man. We don't know. They might launch the missiles because the code's like, when in doubt, launch.
Yeah, so. Absolutely. Yeah. And somebody made that decision, right? Somebody said, hey, 2 digits going to be fine. Right. 2,000 is way off.
We'll figure
Not going
it
to be
out.
our problem.
Yeah. I'm curious because if I read my notes correctly, you recently raised your Series B round, right? I mean, I think you had something close to 25 million?
29 million.
29 million. Awesome. Congratulations on that. Yeah. When did you go out for funding? What was the process, and what's the current climate like from your perspective?
So we went out quite early. We started having conversations probably in January, February last year.
Okay.
There was a lot of interest. It was an oversubscribed round. We got term sheets in May, June, and we finally closed in August, September. I think it was September was the official closing date. So it was a pretty lengthy process, but we spoke to a combination of US investors and European investors. And I think our technology is in an interesting space, and a lot of these investors are not cybersecurity investors as such. They invest in B2B software. Mm-hmm. So I think they find it intriguing. And I think what they like about the cybersecurity space is there's an increasing focus on it. There's, as you said earlier, everything's running on software. So I think in an investor's mindset, this is almost like a picks and shovels play on the information age. We are going to be building more stuff, and we need to make sure that the stuff we build is secure. And therefore, it's going to be a good investment for us to invest in cybersecurity. So we had good response both from US and European investors.
Where is your company technically based?
So we've got the head offices in Spain.
Okay.
And we have a subsidiary in the UK and a subsidiary in the US. So we've got essentially 3 teams. Most of our technical team, finance, legal, back office, and engineering are all based in Spain. And then we have a product team plus sales and customer success and support in the UK, and the same in the US.
And how did that affect the funding discussions? Because I think if I look at Silicon Valley, for example, they're very accustomed to putting money into a Delaware Corp, or possibly I'm in Washington State. There's like 3 or 4 states. They're like, if you want to get funding, you got to be in one. And it's typically Delaware, just because of the tradition and all the infrastructure and the processes that it's very predictable, right? And then I would say like Israel and the UK come on. But if you're in Spain, how did that affect the discussion, or did it affect it at all?
So I kind of had your view going into the B round, partly based on our experience of raising our A round, where some of the US investors are going, Spain's going to be difficult. How are we going to do calls? How are we going to do board meetings? And so on.
Get up early, dude. Just get up early.
So I kind of had that mindset going into the B, but I was quite surprised that a lot of the investors actually liked that setup. And they liked it because they didn't have to pay Silicon Valley prices. So they could say, well, you're a company with relatively low overheads. You've got some teams in the US and the UK that are more expensive, and you're selling to US customers. So you've got the market in the US, you've got the market in EMEA, but the cost base is is substantially less. So I think it was attractive for a lot of investors and also US investors. And it was funny, some of the investors' website that I looked at, even US investors, they would say, we're looking for a startup with this much in ARR, this much in growth, and not on the West Coast. And I was like, what? And they're like, yeah, we're not going to compete. There's just too much competition there. And there are too many VCs chasing too many deals. We want to do a good deal, which means we want to buy good quality, but we want to buy it at a low price. And I think Europe in general is I don't want to say it's a low price area to buy companies, but you can buy very good quality here. The competition amongst the VCs it's increasing, but I think it's nowhere near what it is in Silicon Valley.
That's interesting. I was in Germany, Austria, and Hungary last summer, fall. And I was amazed because from when I was growing up, Germany and Japan were super expensive. I was in Munich and I went out for dinner at a touristy place near the train station, like 100 people sitting outside. And it was like, oh, this is Germany. Oh, And normally you'd spend in the US an arm and a leg for something like this, right? I mean, and I think it was for a dinner and a nice big beer, it was like €13. And tipping is optional. So I was like, whoa, because that's like $13 at the time. So I think we were on parity with the euro at one to one. And which you couldn't even, I mean, here in the States, it would be 3 or 4 times that. I mean, it's just, now I'm sure there are expensive places there, but a lot of services, I think, in Europe, and especially if you go to places like Portugal, Spain, are relatively affordable compared to the US. But one of the things I'm hearing is that as a software engineer, you're in demand anywhere. It doesn't matter where you are in the world. Because of this capability or ability to work remotely, the geo arbitrage thing is all kind of flatlining out a little bit, because you can get a guy in Budapest and say, like, I'm not going to work for less than the guy in Silicon Valley just because I'm here. I'm still doing the same work, right? And you need me because there's a shortage. So walk me through that.
It's interesting because when we started out pre-COVID, we were 100% remote right from the start. So we always worked remotely. We got Slack, like the second tool we ever bought as a company. It was essential to keep working remotely. And we had very little churn within our engineering team. Like, engineers tend to join and stay for a long time. And then when COVID came around, other companies started offering remote work as well. And then we saw engineers leaving the team because a bank now offered them also 100% remote work at rates that we couldn't compete with. So then we saw that, well, we need to start doing things differently here as well. We need to offer other incentives for our developers to stay with us and for us to be able to compete within the marketplace. So we did a survey of our engineers. We said, look, guys, we know that most of you are young or starting families or not. You know what it's like to work with us. We work 100% remotely. What do you want? Like, what's the perk that we can give you that you'd value as a part of the company? And we offered a long list of things, possible things that we'd consider. And one of them was a 4-day work week. And it was the overwhelming thing that almost all of our engineers said, yes, we want a 4-day work week. And we ran the numbers and said, well, the official work week is 40 hours. In Spain, that's really strictly controlled about how many hours you can work every week. So we did the math and said, well, if it's 40 hours a week, if we change that to 36 hours a week, everybody worked 1 extra hour for 4 days. We only lose essentially 10% time. And I would argue that that's not 10% productivity, it's 10% time. And the big benefit is people now have a 3-day weekend, which everybody loves. Now, so far it's rolled out only to the engineering teams, but that's been a massive pull for us and a massive benefit to the teams. And we're seeing that the teams, we haven't really lost any productivity here. The teams like working their 4 days. They give it their all in those 4 days. And then they've got 3 days to relax, unwind, and do their sports and spend time with the family.
Are they on site for those 4 days?
No, remote.
They're remote. Okay. Yeah. I mean, this is a whole other topic that we could probably spend hours on. The whole way of measuring productivity and the whole thing, like, you've got to be on site and work from 9 o'clock until 5 o'clock and take 1 hour for lunch. And human beings just don't work that way. And typically, we've all worked in offices. How much time is, spent at the water cooler, spent doing this, that, the other. It's not like you can just flip a switch and be productive. turn it off.
Yeah.
Be productive, turn it off, But if people are motivated, well rested, they're going to be, by default, they're going to be more productive. Let me ask you though, are you 4 days or 5 days? Or 6 or 7?
No, 5 days.
24/7. You're the CEO, man.
Five and more days. Yeah.
Yeah.
We've ring fenced this around only the engineering team. So the rest of the company works 5 days. And it's just because most of the rest of the company needs to interact with other companies.
Right.
So with our customers, we need to do sales, we need to do support, we need to do all these things where in some cases we need to be available 24/7. So those parts of the business keep running as they did before. It's really just the engineers that have this 4-day perk.
And that's what we were talking about originally in terms of the geo arbitrage and the lessening ability to kind of play that card. Let me just ask you a couple more questions, then we'll wrap this up. You got a lot of books behind you there. All right. Give me a book recommendation.
This one.
Threats. Every engineer.
By Adam Shostak.
It says Threats, what every engineer should learn from Star Wars. Dude, sold. I'm ordering it.
Really entertaining read about threat modeling, right? About look at what happened in Star Wars and with the Death Star. That was a design flaw, right?
Exactly, right?
Yeah.
Like, there was one dude, your job, there was one guy, one team, and their job was just to fix that little thing, and they...
and they didn't do it. Yeah, exactly. That's a good one by Adam Shostak. Just to add that he's written another book as well, which is kind of like the Bible of threat modeling. So if you look for Adam Shostak, you'll find his 2 books. This is his latest one. Recommend this one first because it's more entertaining.
That's awesome. Adam Shostak. And then my last question would be, okay, you can put your sales hat back on. Tell us something that we should look forward to from IriusRisk over the next 6-12 months.
Over the next 6-12 months, we will be releasing a knowledge base and functionality within IriusRisk to allow you to model machine language systems and LLM systems. So you can actually go and have a look at this knowledge now from an organization called BIML, the Berryville Institute of Machine Learning. And they've created a Creative Commons licensed document that describes what are the threats against the machine learning system. Like what are the things that can go wrong and what should you consider doing about that to fix those issues?
All right. I said that was the last question, but you've got me intrigued. Give me an example of a threat in a large language model, LLM.
Oof.
Just give me one. Just give me one. Like one.
One of them will be poisoning the data set, right? If you have access to the data set, you can feed it certain kind of information so that when you go and learn on that data, you're going to be biased in a particular way. And so when you go and run your model, your model is going to be skewed in the way that you want it to be skewed as an attacker.
Dude, if you think about because earlier you mentioned about nation state and you don't have that much visibility on attacks, but if you think about the back office conversations that are happening in some very large agencies around the world where they could say, hey, you know what? We don't have to influence the people directly. We could just influence the M's that are going to influence the people.
Yeah.
It's like, whoa, okay. We're going with conspiracy theory here, but come on, man.
Yeah. No, absolutely. And even financial data, you've got a machine learning system that's going to go and learn on a bunch of financial data and then go and predict prices for you. What does that data look like? Are you sure that you have got the right data set and that somebody hasn't changed any of that data so that your model is going to go and learn something slightly wrong?
That's a whole nother level of it's not even cybercrime. It comes back to like what you're talking about in the crypto space where you're looking at the whole model and finding these. There are tools out there that, for example, insurance companies will look at, and they'll look at like weather patterns, for example, and they'll say, oh, based upon this and that and the other, we need to up our premiums here, or because the risk is increasing. Let's just say for fires, right? The simplistic version. And if you could change that, give them incorrect data, that could affect their underwriting and ultimately their business.
Absolutely.
My criminal brain here is just going. So, IriusRisk is going to come out with.
So we're coming out with that library. It's going to be integrated into IriusRisk, including our free community edition. So if you wanted to go and threat model an ML system, you can go and draw it in the community edition. We'll give you the list. We'll generate the list of threats for you, generate the list of controls, and you can understand, well, what do I need to do to build a secure machine learning system?
That's awesome. Well, I will put a link to IriusRisk in the show notes here. Stephen, really enjoyed this conversation. I would like to wish you and your team an amazing remainder of 2023.
Thanks so much, Mark. It's been great talking to you.
Likewise.
And thanks for having me on the show.
Cheers.
Hello, welcome to Secure Talk, your trusted source of information on the latest threats, trends, tools, and technology related to cybersecurity and compliance.